everyone. Welcome to the global launch of Oracle Database 23 AI. To kick off this monumental release, we've got Juan Loaiza, Executive Vice President of Mission Critical Database Technologies, and a special guest, our founder and CTO, Larry Ellison. So without further ado, over to you, Juan.
Thanks, Kendall. And thanks, Larry, for joining me today for a discussion about Oracle Database 23 AI. This is a game-changing release for the industry. We have over 300 major new features in Oracle Database 23, and we have thousands of enhancements. And there's three main focus areas that we looked at. One was AI, the other one is developers, and the other one is mission critical. And today we're going to discuss some of the major features, the major game-changing features in this release. So let's start with AI. So probably the most important feature in this release for AI is AI vector search. So just to give everyone a little bit of background, AI vector search is a new capability that allows the database to search data by its content. So for example, you can search for documents by its content, not the words in it, but the overall content and concepts in it. You can search for images, you can search for videos, you can search for audio. You can also search relational data by its conceptual content. So your thoughts on AI vector search, Larry?
Well, being able to look at converting everything to vectors. Converting an image, converting a string of base pairs for DNA, reducing everything to a vector allows the database to actually find similar pictures. So if I want to find all the pictures of Juan Loaiza in my album, I can do that. Actually, I tried that yesterday, Juan. I don't have any pictures of you, but I confirmed that with the new Oracle vector search. The system allows us, as you say, to search the contents of the data and find similarities. We've had vector searches and similarity searches for a long time. This is not one of the newer things, but the vectorization. But now it's all stored in the database. All these we can convert virtually anything. A language. That's how the large language models work. They convert language into vectors, and they look at phrases that are similar. They can find phrases that are identical or almost identical. It's how they track down plagiarism, by the way. Right now, plagiarism is virtually impossible, because I can do a vector search and it doesn't have to be an exact match of what you wrote, but if it's very similar to what you wrote, the vector search will find it. And it's this interesting ability to embed, to convert data into vectors and then find vectors that are similar to one another, or what they say, it's close in the vector space.
Larry, what are your thoughts on vectors? Should these be delivered as a standalone product, or should they be delivered as a feature of a database?
I think it's a feature, and there were XML databases. If anyone's old enough, I'm old enough to remember XML databases. Every time there was a new data type, if you will, every time there was a new feature, someone thought this was a great opportunity to develop very quickly develop and deliver a new kind of database. And again, XML is maybe my favorite example. It didn't last very long, but we had object databases, we have relational databases, but the answer is, I think the answer is always that all of your data should be in one place. It just makes life much easier to ask a question, ask a query that spans. You don't anticipate the query you'd like to have. The hardest problem usually is finding the data. But if you keep all the data in one database, it requires that database handles every data type, whether it's a graph data type, whether it's a vector, whether it's XML, whether it's an adjacent document, whether it's a SQL table. So we think that the right way to approach this problem is to have a database that can manage all of your data, and then do it in a highly performant, very economic way.
It's interesting new technology, and other areas are finding anomalies, which can be things like fraud, or broken parts in a factory, things like that. So it has a lot of different applications. And of course, one of the main ones is to combine it with LLMs, with AI chat. So now you can basically do natural language AI chat with the data in your database. So for example, you can ask it questions about your bank account or your phone account or your medical history. And the Oracle database will take that question and use AI vector search to find relevant data in the database. So your medical records, your account data, your phone records, and then we can answer the question using the LM, again, using natural language. So that's a big new thing.
Yeah, well, they call that retrieval augmented generation, where we can do that a couple of ways. We can do that with prompt engineering, where you can actually include some of the data before you ask your question. You kind of tell the large language model, give it some context before you ask your question. But actually, that doesn't scale very well. And by putting specializing and personalizing large language models with your data is something you can do with the Oracle vector database. So you have a foundational model that is trained, but it doesn't know, it obviously doesn't have your banking records, and it doesn't have your personal email. That's not public data that these large language models are trained on. But you can specialize these large language models with your personal data. That's one of the things we can do. You can specialize these large language models with the latest clinical research papers that have been written and come out in the last month or so, and to make sure that the foundational model is up to date in its training. It is up to date, up to the minute, because the very latest news is in the vector database. The other stuff was available when the foundational model was initially trained.
Yeah, so that combination of database and the LLMs is going to be amazing for users. A lot of amazing new capabilities that were never possible before. We've also added AI all over the place. We've added AI to Exadata, to Accelerate AI. We've added AI to Golden Gate, so you can distribute your vectors across your entire enterprise. You can pull in data into Oracle Database 23 that you want to vectorize and do AI search on without having to upgrade your production database right away. So there's a lot of new capabilities. Do you want to describe what our pricing philosophy is on this AI technology inside the Oracle database?
As you and I discussed before we made the decision, we think this is a transformational technology, artificial intelligence, and we think that the Oracle database, the Oracle vector database, is a highly scalable, very powerful, highly secure system that can store your personal data, highly secure data, medical record data, those kinds of things. Keep that data very, very secure, yet use that data to make the neural network smarter. And we think that is so important. We want to encourage use. We want many people to see this capability and use this capability as quickly as possible. Therefore, it just, as my mother would say, comes with a meal. There is no extra charge for these AI capabilities. They're built in to 23 AI, the latest version of our database, and everyone can use them.
Yeah, so it's just there. So AI is the new normal. It's just going to be everywhere, and we're making sure that it's available for all your data. So let's move on to another topic, developers. It's another big focus for us, making developers more productive, making data easier to use by developers. So a big focus of ours was the unification of JSON, graph, and relational. So we've had JSON and graph available in the Oracle database for a lot of years. We have literally industry-leading technologies. But up to now, you've had to choose one. So you format your data as either relational, JSON, or graph. And once you've chosen that one format, you get all the benefits of that format, but you also get all the limitations and drawbacks of that format. So the big new thing in 23 AI is we've unified these. So now you can store your data once, and then one part of the app can treat it as relational and access it using SQL. Another part of the app can treat it as JSON, both read and write it as JSON using JSON API. So you get all the benefits of JSON. And then another part of the app can treat it as a graph and run graph queries. So we think this is a huge development not just for us, but for the entire industry. And it will greatly simplify development, make developers much more productive. So you've been around this whole object, representing objects, has been an issue for databases for decades. And you've seen the evolution of this thing. What are your thoughts on this new technology?
Well, I can just tell you from our own experience in building applications, the first thing people decide, well, am I going to build fundamentally an object schema, or I'm going to build fundamentally a relational schema, two-dimensional arrays, and there seemed to be no right answer, because at Oracle we built some of our applications with object schemas, primarily object schemas, which we had to manage at the application layer, and we built some of them with underlying relational schemas, and that and then we do a mapping between, but we would always do a mapping between the objects and the relations, because a lot of the transactions, a lot of the data entry is more convenient in JSON objects, and people don't like to, before they start programming, completely define their relational schema. A lot of programmers resisted SQL, and NoSQL used to mean NoSQL. Now it means not only SQL. They decided they really didn't want to give up SQL entirely. But a lot of programmers want to start building their application and start collecting information as quickly as possible. And they don't want to work out in advance what their schema is going to be. So what we did is let you, define your JSON objects, and we will generate the relational schema from that. And the beauty of that is you can then query all your data, which is very hard to do if you actually use an object database. Having a powerful query language is not something object databases come with. And it is fundamental to relational. So we have all the power of the SQL query language to sit on top of the objects, but you can view them as objects, JSON objects, or as relations. They coexist. You do not have to predefine the schema. You're a programmer, you can get started writing your application. But the trouble they get into is when they write their application without predefining the schema. If they want to make a change, they want to evolve that schema, they want to add things to it, they want to modify things. It's very difficult to do with an object like schema. With underlying relational schema of evolution is quite easy. So there are advantages of objects, there are advantages of relations, two-dimensional tables. With Oracle 23 AI, you get both. You get all the advantages of objects. You can use objects. From your point of view, you can think of it entirely as an object database. Afterwards, you say, wait a second, I need a powerful query language, and I need to do some schema evolution. No problem. It really is both. You get the best of both worlds with this unification, and it's completely seamless. Some users can think of it one way, some users think of it the other way. It all works.
Yeah, so this is a problem that we've been trying to crack for decades, and we feel like we're there now. This is it. It actually, once you figure it out, it's much simpler than some of the things that we tried in the past. It's interesting.
Oh, it's all automated. We used to have to do this at the application level, right? We had to do a lot. It was never completely transparent to move from objects to relations. The application had to be aware of it. Now that's not true. The application developer, the users can see objects if they want to, pop a switch and they see that same data in relations. They can operate through both sets of APIs.
Right, and graph is yet another benefit, which is you can run these graph queries to navigate, right?
Yeah, graph is yet another example of a model that we've incorporated. So we really have unified 3 separate models into 23 AI.
Right, and it's not even application by application, it's use case. So you can use it, one format, then use it in a different format.
Well, exactly. I said you can build all your data entry applications using the JSON schema, and you can build all your analytic applications using SQL tables,
right?
And the SQL language. And those two different use cases, same application, same data, same everything, just different use cases. Analytics versus data entry.
Yeah, that's great. So you mentioned NoSQL. So in the last decade, there was a big push for NoSQL and also for getting rid of transactions. Transactions were considered kind of at best an annoyance, and at worst kind of a problem. And so there was a move to move transaction management into the application. Now, one of the things we've done with Oracle Database 23 AI is we've addressed some of the long-standing problems with transactions, because transactions had some issues. So among those are stateless transactions, so like REST transactions. You know, how do we read data and write it back and make sure that nobody wrote it while I was looking at it? Another one is long-running transactions. We don't want to lock a row for a long time that blocks out other users. And another one is microservices. How do you keep the microservices consistent? So these are areas that we put a lot of work into. So I think, you know, already that trend toward moving transactions into the application is really kind of dying out because people have been trying it. It's not working so well. So now I think we'll really kind of get back to, you know, data integrity. I mean, the whole idea of data integrity is kind of, a lot of people have lost track of that, data consistency. So your thoughts on this?
Well, again, it's a matter of rediscovery. Transactions can have complexity, certainly long-running transactions, holding locks for too long. You know, Oracle's always had a unique locking model. We really don't, we have update locks, we really don't have read locks, which is very unusual. I'm not going to spend a lot of time talking about it, but it solves a lot of the long-running transaction problems already. But it wasn't, but there were certain cases where long-running transactions were a problem for the Oracle database as well. And we've addressed that. And by the way, moving this into the application, you simply saying, okay, I've got this great idea. Rather than solving the problem once in the database and the application developers don't have to worry about it at all, how about every time you write an application, you have to handle data consistency in the application? Well, it makes your application almost impossible to write. And it makes your application 10 times harder to write. It's not really a very good idea. As much stuff you can shove down in the stack, the better, to ensure you got data. Same thing with security. You want to shove that down. You don't want the application developer to be responsible for security. You don't want the application developer to be responsible for for data consistency. That should be the responsibility of the database. So the application developer focuses on getting the job done, building that application and inheriting from below, from the database, both security, consistency, reliability, all of that should be done at the database level, not the application level.
Yeah. The idea of the integrity of your data is as good as your worst developer on his worst day. You know, yeah. What do you think of that idea, Larry? Is that a good plan?
I think because we're a very unusual hyperscaler. We both provide infrastructure, things like autonomous Linux and the Oracle Autonomous Database, and we also build a lot of applications, whether it be in healthcare or in ERP or human resources. We build a large bunch of different industries. We build a lot of applications, and again, I think you want those application developers to be highly productive, and so you don't want to burden them with the problem of getting data consistency right. And plus, you really don't want to have to audit every single application to make sure the data consistency is programmed properly in the application. That should be something you simply inherit from the underlying infrastructure, from the underlying database. Let's keep the application developer focused on what the application does, not on underlying problems like data consistency.
Yeah. So here's another related issue that new technology has come around, which is caching in the middle tier. So caching the database in the middle tier. Yeah. So there's a number of products now in the market that cache data. And the way this works is the actual application developer reads the data from the backend tier and puts them manually into the cache and then manages their consistency in the cache. So this is kind of what's in the market. One of the features that we've added to Oracle 23 is called True Cache. And what this is very simply a real cache, a true cache, not a faux cache. So we have a cache in the middle tier. The developer just runs the regular database operations against that, query, SQL, JSON. As it finds data not in there, it'll automatically pull the data from the database. You don't have to do that manually. And then once it pulls the data in there, the database will automatically keep it consistent. So you don't have to worry about, hey, somebody changed the data and I have a stale copy of the data and now I got to deal with this thing. Right. So again, very similar thing. What are your thoughts on this whole area of caching in the middle tier?
Well, I think what people were doing at the application level, building their own middle tier caches, was just a way of monitoring the market and seeing that they wanted better performance. So someone once joked and said there are three ways to improve performance. There's caching, caching, and caching. I think that's a bit of a simplification, but there's an element of truth in that. So having this mid-tier cache for the database is very important. But once again, it shouldn't be done at the application layer. The application should just expect the database to provide that kind of performance by storing a data consistent cache for them in the middle tier. So they should get the improved performance without going into making any extra effort in their application. And that's what we've done by providing true cache.
Yeah, so basically it's impossible to keep it consistent. You can't, even if you try. So this is a case where no matter what you do, because you don't know when someone's changing the data in the back end. So, and your data goes forward and backward in time because part of the data, you loaded earlier and later and it's changed. And, going forward and backward in time in the application, that's a hard problem.
It is a hard problem, but a lot of things that they take on at the application layer is, let's call it, a digital cry for help. Okay, look, I just need this performance now, so I'm going to try to do it this way in the application because you're not providing this for me. So we watched what was going on in the marketplace. We realized we could dramatically improve Oracle's performance from where we were with this. The idea of a mid-tier cache was a good one, but let's make sure we do it properly in the database and not burden the application developer with that.
Yeah, that's exactly right. So one other thing, let's talk about one more thing, which is globally distributed data. So now there's more and more countries that are passing data sovereignty, data residency laws. So that means that country's data has to be stored inside that country. However, if you're an enterprise, you want to see the data as one global unit, as regardless of what country's in, so you can run your operations on that. And for that, we've introduced something we used to call a sharded database. Now it's called a globally distributed database. And it has two main functions. One is you can place your data wherever you want in the world. So European data goes in Europe, Indian data goes in India, American data goes in America. Everybody's happy, and it's all transparent. The other thing, of course, you get much higher scalability. So this is a technology we've been working on for a long time. We've been enhancing it. In 23, we've enhanced it a lot. We've added something called raft replication, which allows much faster failovers, in single-digit second failovers when you have some kind of an issue. So what are your thoughts on the whole data regulation, data sovereignty? This thing presumably is only going to increase over time?
So we keep the illusion of a single database. Even though it is not a single database, it's partitioned geographically. There are also partitions that exist for reliability purposes and performance purposes. There are caches and there's lots of copies of that data. But once again, automatically we adhere to the different data sovereignty laws in every country. The Swedish laws might be somewhat different than the Ukrainian laws. And we implement this and implement the requirements of what data has to be in Sweden, what data has to be in Ukraine. We implement that all automatically. And from the point of view of the organization that owns the data, that's running the application, it looks like a unified global database. But from the point of view of compliance, regulatory compliance, we partition it and obey all of the rules. So we just, once again, trying to make life easier for people who are developing these applications and have to build global applications yet comply to local sovereignty laws.
Yeah. Yeah, so overall, we talked about a number of these technologies that they're not just better, they do things that were never possible before. So the AI, the vector search, the LLMs, the ability to do transactions across microservices, long-running, distributed, things like the true cache, we talked about the distributed database, the JSON unification with relational, graph unification with relational. These aren't just additional features. These are things that have been pain points for the whole data management industry for decades, forever, that we're addressing in this release. So it's really, I believe, a monumental release. So what do you think of the overall package?
Well, the overall package, again, we solved a lot of problems. The object relational unification is, I think, one of the biggest deals from the logical level of the database, one of the biggest things we've ever done, one of the most important things we've ever done in terms of ending the debate, should it be a relational schema or should it be an object schema? And the answer is simply yes. We need it needs to be both at the same time, because that debate never ended. But now you can have the best of both worlds. We can actually deliver that. AI, as you say, is this extraordinary new technology, and and as we know, these models are trained on all the data on the internet, all the language on the internet, and lots of images as well. It's not just language that they train on. But they're not trained on your personal data. They're not trained on your corporate data. Your proprietary. They're not trained on a lot of medical records because that data is private. But the great thing about our vector database, it allows you to supplement the training of the foundational model, whether it's ChatGPT from OpenAI or Grok or Llama or what have you. You can supplement the training of that model with your personal data, with your proprietary corporate data, with private data, without having to disclose that data to the people who are building those models. So you can specialize the AI for your company, for you personally, for a particular topic, like a certain type of cancer, to make sure you've got all of that data in a single place. So the model is smarter than it otherwise would have been, because you can safely add your private data to that. So because you want that data should be anonymized. The patient identifiers won't be there if you're collecting a lot of cancer data, but the anonymized data will make much better recommendations to doctors about how to treat a cancer patient. Having that data there is going to means we can get better recommendations on how doctors treat cancer, and I think that's a very big deal. Or how in Wall Street they'll want much better recommendations on what stock to buy next. We're focused on healthcare at Oracle, building healthcare applications, but there are lots of applications for this technology.
Yeah, and all the new transaction capabilities, transparent caching, distributed data. So I think it's not just another release. It's really kind of a monumental milestone in the industry.
No, absolutely. I mean, AI. I mean, I remember I gave a presentation a little while ago. It says, "Is AI the most important technology in the history of IT?" And I think I said maybe we'll find out very soon. And the answer is probably yes.
Yeah, maybe transistors and AI. Those are the two big things. Okay, this has been a great conversation, Larry. Thank you.
Thank you so much, Juan and Larry. What an exciting conversation. And hey, for all of you tuning in, if you want to learn more about Oracle Database 23 AI, go to oracle.com/database. Bye.